Welcome to topic number 22, normal distribution part 2. So in this video, I will show you how to find probabilities using a normal distribution. So we will do some application problems, and we will also learn how to actually find the z-score by given an area under the curve. So we'll do two different things here. All right, so how do I find probability area under the curve for application problems? So basically, we're going to find the z-score, draw a normal curve that help out to know exactly where on the graph I'm looking for. Share the desired area from the curve, and then find the area under the normal curve. So we were gonna do all 4 steps, and I also add a couple other extra steps to help us to find the z-score. So for the scenario below, complete the following. So the ARC Electronic Company had an income of $104 million last year. Suppose the mean income of firms in the same industry for a year is 85 million. So that got to be the population mean with a standard deviation of $19 million. So that got to be the 19 million got to be the standard population standard deviation. If the income for this industry are distributed normally, what's the probability that a randomly selected firm will earn less than ARC, which is this company ARC last year? So this problem want me to find less than. Okay, so this is a random variable X population mean and the standard deviation. So if 85 is a population mean, 19 is the population standard deviation. So 104 million got to be the random variable X for this company 104. All right, population mean mu is equal to 85 million, comma, and standard deviation 19 million. So find the z-score. So my z-score z got to equal to 104 based on the formula, minus the mu divided by standard deviation, minus 85 divided by 19. So in the calculator, 104 subtracts 85 first, which is 19 divided by 19. Then my z-score is going to be 1.00. So from the scenario above, the probability area on the curve is to the left, to the right, or in between the z-score. So I'm looking for less than got to be to the left. So here I have a graph right here. So my z-score is 1. So the mean is at 0 here in the center. 1 is to the right. I'm looking for a probability to the left, right? Less than is to the left. So what is the probability that a randomly selected firm in the same industry, okay, will earn less than this company who makes 104 million? So write out the computation above scenario using the graphing equation. So I'm looking for the area to the left, so there will be normal CDF. Okay, my left, how left do I go? So I don't have a lower bound, so that's negative 1E99, comma, all the way up to 1, comma 0, comma 1. All right, let's round to 4 decimal places for number 5. So normal CDF, negative 1E99, comma 1, comma 0, comma 1. 0 is the mean, 1 is standard deviation, and this 1 right here is the upper bound. So the probability is about 4 decimal places, so it'll be 0.8413. Okay, let's try another scenario. A soft drink machine outputs a mean 26 ounces per cup, so that's the population mean. The machine's output is normally distributed with a standard deviation of 2 ounces. What's the probability that overfilling a 29-ounce cup? So overfilling a 20-ounce cup, so that's my random variable X, 29. My mean is 26 cups, right? The machine normally output 26 cups. Standard deviation is about 2 ounces. All right, so find the z-score of the random variable X. So let's convert the 29 into a standardized score. So that's 29 minus 26 first divided by 2. So that's 3 divided by 2, which is 1.50. All right, so overfilling 29-ounce cup, overfill got to be area, looking for the area to the right. So far, Ming is right here in the middle. 1.5 is to the right. I'm looking for the area to the right. I'm looking for the probability to the right of my 1.5. So that helped me do the computation. So using the calculator, normal CDF, right? I'm going to the right, so 1.5 must be my lower bound. My upper bound is positive infinity. We would use 1E99, comma 0, comma 1. All right, 1.5, comma 1E99, comma 0, comma 1. All right, so my 4 decimal place, that'll be 0.0668. 0 made the 8 stay the same. All right, let's look at another scenario. So this one is in between. All right, the time spent waiting in the line is approximately normally distributed. The mean waiting time is 6 minutes, the variance. So this one is giving me variance, not standard deviation. Waiting time is 1 minute. Find the probability that a person will wait in between 5 and 7 minutes. So my random variable X will be 5 minutes, waiting 5 minutes, waiting 7 minutes. Population mean normally is wait times about 6 minutes. And the standard deviation, so so what I'm given here is a variance. Variance is sigma squared. So the difference between variance and standard deviation is by the square root. So if I take a square root of my variance, my square root of 1 got to be positive 1. All right, so I got two z-score I gotta find. First one is the 5 minutes divided by 1. Standard deviation is 1. So 5 minus 6 is -1 divided by 1 is -1.00. The other z-score is 7 minus 6 divided by standard deviation 1, which is positive 1.00. So I'm looking for, so if the mean is right here, I'm actually looking for the area in between -1 to +1, which is right here in the middle. All right, so this problem is in between, because the problem kind of told me that already, in between. All right, right of the computation. So in between, so I'm looking for the area in between. So -1 is my lower bound, upper bound is 1. So normal CDF, -1 to +1, comma 0, comma 1. -1 to 1, comma 0, comma 1. Okay, so that'd be about 0.6827. 27. There you go. That's the area. So that's the probability. So what it's saying is the probability that a person will wait in between 5 and 7 minutes is about 68.27% chance. All right. So now I'm going to show you how we can find the z-score by given an area under the curve. So to find z-scores, again, we can actually look up the table. We're going to look up the closest probability in the table or use a graphing calculator. So let's try to use the table first, okay? So remember, the table always give me the area to the left. So from the standard normal distribution, find the z value such that 0.03 of the area lies to the left of the z. So I don't really know where my z is, okay? But I know the area to the left is already 0.13. So on the table, to do this on the table, I'm gonna go look for area to the left, 0.13. So if you look at on the negative side, okay, this is very negative, right? 0.0038, 0.13. So let's find 0.1 first. So if you keep looking, 0.0, 0.0, 0.02, okay, keep on looking 0.03, 0.04, 0.08, all right, 0.13. So this is 0.100. Okay, so 0.102, I'm looking for 0.13. So you just keep on looking, 0.1292. Now I don't have a 0.13 exact, but I got a 0.1292 and 0.014. Excuse me, 0.1314. So which one is closer to 0.13? Well, 0.1314 is 0.0014 place away. This one is only 0.0008 place away. So this one is closer, not that one. So this one would be negative 1.1 and look up to the top, 3. So that's how I actually find it. Negative 1.1 and then look up to the very top row, 3. There you go. That's how we find it. So the z-score is right here. So the area to the left of that, this area is 0.13. All right, let's try another one. For the standard normal distribution table, find the value of z such that 0.9722 area lies in between. This one's a little bit tricky, in between negative z and z. So basically, here I have a negative z and a positive z. The area in between them is going to be 0.9722. Okay. So if I can find one of these two z's, if I can find one of the two z's, then I basically have, I basically know what my z-scores are. Okay. So what we want to do is find the area to the left of the negative z. Because if I can look up in the table, if I can know what this area is, then I can look up on the table to figure out what this z is. And the other one is just a positive version of that one. So the 0.9722 is in the middle, right? So that means this area and this area had to be exactly the same. So we take 100% minus 0.9722, then divided by 2. So 1 minus 0.9722 divided by 2. So this area right here is 0.0139. Okay. So the area to the left of negative z is 0.0139. So on the table, 0.0139. Let's look. 0.013. So 0.011, 0.0139 is right here. So that's negative 2.20. So if this is negative 2.20, that one got to be positive 2.20 because the area to the left of this z and the right of the positive z is the same. Okay. So when it comes to using a calculator is a little bit quicker. Calculator, we will go back to distribute again, second vars. This time we will use this thing called inverse norm. Inverse norm allows me to find the z-score. So normal CDF give me area to the left of a z-score. Inverse norm actually give me the z-score. Okay. So what we're going to put inside the inverse norm is the area to the left, comma 0, comma 1. 0 is the mean, 1 is standard deviation. So to find the z-score, you got to use inverse norm. To find the area under the curve, we use normal CDF. All right. So to find the value of z such that 0.13 area lies to the left of the z-score. So this is the same as earlier, I'm using a calculator. So number one says compute the area to the left. We always gotta know what the area to the left is, which is 0.13. So from the correct answer, number one, right out the computation. So my computation for number two got to be inverse norm. Okay, what we put in here is 0.13 area to the left, comma 0, comma 1. And so this is going to give me a z-score. Okay, z-score, 2 decimal place. So second vars, distribute number 3. Okay, 0.13 area to the left, comma 0, comma 1. Voila, negative 1.13. There you go, that's my z-score. Okay, so this time, again, just like earlier, in between negative z and z. So we're going to use exactly the same approach. Compute the area to the left of the negative z-score. Okay, so we're going to do exactly what we did earlier. Take 1 minus 0.9722 divided by 2. Because I'm trying to find the area to the left of this negative z on the left side of it, on the left side of the mean. So earlier we got 0.0139. Okay, so 0.0139 is the area to the left. It's right here. This is the area. So number two, if I do inverse norm of the area to the left of negative z, 0.0139, comma 0, comma 1, then what's going to happen is it's going to give me this z-score because the area I put in is for this z-score. Okay. So number 3, let's see what that is. Okay, 0.0139, comma 0, comma 1. All right, negative 2.20. So the other z-score must be the positive 2.20. If you don't believe me, then what we can do is find the area to the left of this z. Area to the left, this z got to be 1 minus area to the right, right? Because 0.0139 is the area this side and area on this side. It's area for both sides. So if I will take 1 minus the area to the right of my positive z, 0.0139, then the area to the left of my positive z, the area to the left, the whole entire area to the left, not just right in the middle, the whole entire area to the left is 0.9861. So if I do the inverse norm of 0.9861, comma 0, comma 1, it'll be positive 2.20. And that's one of the characteristics of a normal distribution. It's symmetric. Okay. All right, let's try some application problem. Okay. So scores on the test have a mean of 71.6 and 6% of the score are above 87. All right. The scores have a distribution that is approximately normal. So if I list my random variable X, okay, gotta be this 87. The mean, population mean is 71.6. All right, this 6% of score are above. So what? So this word above tells me, okay, so think about this. The mean is 71.6, 87 to the right of it. Okay, so we know the mean under the standard Z is 0. So the area, okay, the 6% is referring to the right of 87. That's where the 6% is, which is 0.06. Okay, so in order to find the z-score for this 87, I need to find the area to the left first before I can use the inverse norm. Right, inverse norm give me the z-score. So compute the area to the left. So that will be 1 minus 0.06, which is 0.94. So to find the z-score, Okay, 0.94 is all this area to the left of it. So that will be inverse norm. Area to the left of my 87 is 0.94, comma 0, comma 1. Right? So my z-score, let me put right here. .94, comma 0, comma 1. The z-score is 1.55. So this is 1.55. Okay, that's a z-score. That's a random variable x. So number 4, from the answer in number 1 and 3, right? Find the standard deviation. So this problem will actually want me to find the standard deviation. So for number 4, you know what? Let me erase this. I'm gonna move up here so I can have more space here. So for number 3 is inverse norm 0.94, comma 0, comma 1. So my z-score equal to 1.55. So for number 4, think about our formula. Z equals x minus mu divided by standard deviation, right? So now I got my z, 1.55. I got my random variable x, which is 87, minus the mean, 71.6. Now I can solve for sigma. All right, so we will use a basic algebra technique, cross product, 1.55 over 1. Okay, use a cross product, multiply diagonally. 1.55 times sigma is 1.55 sigma. Set it equal to 87 minus 71.6. 87 minus 71.6 is 15.4 up here. 15.4 times by 1. Okay. So you know what? I'm gonna write this in a couple of different steps. This is 1.55 over 1 set equal to 15.4 over sigma. All right, so cross product. So that will be 1.55 times sigma set equal to 15.4 times 1. 1.55 sigma equal to 15.4. So to get sigma by itself, we divide both sides by the coefficient 1.55. So sigma equals round to 1 decimal place. So that's 15.4 divided by 1.55. 9.9. So my standard deviation is about 9.9. All right. Let's try another one, okay? Suppose ACT mathematics scores are normally distributed with mean of 21.3, standard deviation 5.3. A university plans to send letters of recognition to students score are in the top 11%. So top 11%. All right, so the mean is 21.3. Top 11%. So let's say this is the top 11%. Right, top is to the right, which is 0.11. So the question now becomes, okay, what is the score gonna be? What is this score to determine the top 11%? So number 1, list a population mean, which is 21.3, and a standard deviation 5.3. The area to the left of my z-score, right? So the top 11% is to the right, to the left of my z-score that I'm going to find will be 1 minus 0.11, which is 0.89. All right, so to find the z-score, inverse norm, area to the left, comma 0, comma 1. So that will give me the z-score of this, that will give me the z-score for that score I'm looking for. .89, comma 0, comma 1. The z-score is 1.23. Go on to 2 decimal place, 1.23. Oops. Okay, so that is the z-score. So we actually found the z-score here, 1.23. So again, using that formula, z equals x minus the mean divided by standard deviation. I got z-score 1.23. Set it equal to the random variable x is what I'm looking for. I'm looking for that score that will determine the top 11% minus the mean divided by the standard deviation, which is 5.3. All right, so use that cross product technique again. So I normally start diagonally what my variable is. 1 times those two terms is still going to be x minus 21.3. Set it equal to 1.23 times 5.3. 1.23 times 5.3. That's 6.519. All right, to get x by itself, we will add 21.3 on both sides. So add 21.3 on both sides. Run to 1 decimal place, so that'll be 27.8. So the ACT score, 27.8 is the score that separate the top 11% from everybody else. All right, let's try this one right here. The diameter of bolts produced in a machine shop are normally distributed with a mean of 5.66 milliliter and a standard deviation of 0.03 millimeter. Find 2 diameters that separate the top 9% and the bottom 9%. Okay, so here on my graph, I'm trying to find the diameter that separates the top and the bottom 9%. So this is where the 9% is at. Okay. So list of population mean is 5.66. Standard deviation 0.03. So compute the area to the left of a z-score. Okay, so here I basically have 2 different z-scores, right? To the left of this negative z-score, because you know this is a positive z. So to the left of a negative z, okay, so 9% is 0.09. So I have 0.09, and to the left of a positive z-score, so to the right is 9%, so to the left of it got to be 1 minus 0.09, which is 0.91. So to the left of this z-score, the whole thing is 0.91. So find the value of z. So basically I had 2 z-score I'm gonna find. So these two answers is only differ by the signs. Okay, so if I do inverse norm of the 0.09, comma 0, comma 1, that will give me my z-score. Oops. Inverse norm 0.09, comma 0, comma 1. That'll give me the negative 2 decimal place, negative 1.34. So that's what that is. All right, the other side got to be positive 1.34. So if I do inverse norm 0.91, comma 0, comma 1, it'll be positive 1.34. There you go. Okay, we're not quite done yet. That's just a z-score. We need to really find the actual diameter, actual x. So same formula, okay? So I got mean, I got standard deviation, now I got my z-score. So this one right here, this x value right here is for the negative z-score. So that's negative 1.34, set it equal to 5.66, excuse me, x minus 5.66 divided by 0.03. The other one is positive 1.34, set it equal to x minus 5.66 divided by 0.03. Okay, so again, cross product for both. So x minus 5.66 times 1 should be x minus 5.66. Set it equal to negative 1.34 times 0.03. Negative 1.34 times 0.03. Negative 0.0402. So the other one got to be positive 0.0402. All right, so add 5.66 on both sides. All right, so the negative 0.0402 plus 5.66. Okay, round to 2 decimal place, so that will be 5.62. Now the other one is the positive 0.0402 plus the 5.66. So that gave me 5.70. So the two diameters separate the top and the bottom 9% are 5.62. And this is a Z, this is the X, and the 5.70. Okay. All right. One more thing I want to talk about the area is this notation later on I will begin to say a little bit more called Z sub alpha. Okay, Z sub alpha is referring to the Z score such that the area under the standard normal curve is to the right. All right. So alpha is the area to the right. So for example, if I will say Z sub 0.1, that means I'm looking for the Z score whose area to the right is 0.1 of a Z score. Area to the right of a Z score is 0.1. So how do you go about finding that? Well, you got to use inverse norm because inverse norm always going to give you the Z score. So basically you got to use inverse norm. And what you put in the inverse norm is the area to the left. So if the area to the right is 0.1, area to the left got to be 0.9, comma 0, comma 1. So that will actually give you the Z score for that. Okay, that will actually give you the Z score whose area to the right is only 0.1. All right, on the homework is pretty much the same as I just went over. So just follow these steps. Make sure you use graphical equation to enter all the answers. So for number 1, make sure you enter what I asked you to enter. Okay, you got to use graphical equation for your random variable X population. Mean is mu and population standard deviation use sigma. So I kind of went over, well, where these symbols are on the syllabus videos. Okay, that's why I asked y'all to learn how to type those in before. Okay, but if you're not quite sure where they're at, just make sure you can either revisit the you can revisit the last question of our syllabus and welcome video, or just ask me and I will show you where they're at. Okay. All right. Thank you for watching this normal distribution number 2.